Let's set up and run a simple flow analysis. Start by opening your starter file and navigating to the imported bodies. Isolating my first body, I see this cold plate that we're going to simulate fluid moving through. In the Display tab on my right side panel, I can check the transparency box so that we can see what's going on inside of this plate. My second variable represents our fluid body. This is the fluid domain we plan to model for our flow analysis. Now navigate to the Fluids tab in your ribbon to view the flow analysis tools that you have available. I'll drop our line into our flow analysis section in the notebook, and from the analysis dropdown, I'll add a flow analysis block to our notebook. This flow analysis block is going to intake a model, boundary conditions, and a cell size, and output the results of our flow analysis. At any point, you can navigate to the right side panel and view the Information tab to read about our blocks, as well as their inputs and their output. Let's begin by building our simulation model that we want to analyze. To keep things organized, I'll drop my cursor into this Simulation Model section within my notebook. Then, from my Model dropdown, I'll drop a simulation model into my notebook. Notice that this simulation block has an overload from which we can select an FE domain list or a virtual domain list. The FE domain list will apply to our FE models that we use for structural and thermal analysis, and our virtual domain list is going to apply to our simulation models for flow analysis. At this point, we can right-click on our simulation model block and make it a variable. I'll name this variable Simulation Model, and drag this variable chip into our flow analysis block so that flow analysis can reference it later on. Drilling into this simulation model, we see that we have two main inputs, the domains and the connectors. For flow analysis, we can ignore this optional connectors input. Let's expand this virtual domain list and build out our fluid domain. At this point, we can expand our model dropdown and add our fluid domain to our notebook. Or instead, we can just double-click into our virtual domain list and view our domain options. I'll add my fluid domain, and now we see these two inputs, our body and our attribute. Let's start with our body. This is going to represent the geometry of our fluid domain. We can drag and drop our fluid body into that body input, and then move forward to describe our material properties. We'll do this in our fluid attribute block, where we can define our isotropic material. Again, I can double-click into this input to view my material options, or I can expand my material information in my Fluids tab. As we can see, we already have two materials that are available to us, air and water. We can also define our own fluids we want to simulate. To do this, we can use the isotropic material block. We'll drag and drop this into our isotropic material input, and now we can define its properties relevant to flow analysis. Those two properties will be density and kinematic viscosity. Say we want to simulate antifreeze. Let's add a density of 1,114 kilograms per meter cubed. Next, we can add our kinematic viscosity. Since this is inherently a fluid property, we can come back up into our material information and add in an isotropic fluid property. We can drag and drop it into our isotropic material, then add our kinematic viscosity of 1.78 e to the negative 5 meters squared per second. When I hit enter, I see that all of my block details are turning gray. My simulation model runs. And if I isolate using the hotkey I see my resulting model. Since prior to building this simulation model, we already turned it into a variable and referenced it within our flow analysis, it's going to be recalled later on when we run that analysis. To keep our notebook organized, maybe we want to add a couple more variables throughout this first section. This will help our future selves and colleagues follow and understand our setup. I can right-click on my isotropic material and make it into a variable. And I'll do the same for my fluid domain. I'll collapse each of these variables, and we've finished setting up our simulation model.